So the assignment particle physics and particle accelerators. I have discussed the first 5 questions from this assignment last session. And question 6, in 1908, Rutherford, Giger, and Marsden investigated the interaction of alpha particles with matter. In one set of experiment, they directed the alpha particle towards a thin gold foil. State why alpha source and a gold foil are contained in a vacuum. So what is the reason for that? Why we should have a perfect vacuum? So that these alpha particle does not interact with the air particle. Otherwise, when these alpha particle collide with the air particle, so air will not allow these alpha particle to pass through. So air molecules will stop the alpha particle. That's why we should have a perfect vacuum, because the alpha particle penetration of alpha particles is about 4 to 5 centimeter in air. So when we have a perfect vacuum, there will be no collision between the alpha particles and the air molecules. As a result, the alpha particle can hit the metal foil or the gold foil. In part B, at that time, one model for structure of atom was plum pudding model, which was proposed by J.J. Thomson. In this model, the positive charges and the masses are separated evenly throughout the atom. Negatively charged electrons were distributed within an atom. Discuss the extent to which the results of alpha particle scattering experiment justify replacement of a plum pudding model with a nuclear model. So in a plum pudding model, what is the structure of an atom? That the positive charges and masses are separated evenly throughout the atom. And negative charge electrons are distributed within an atom. So positive and negative charges are there. Anywhere we can find positive and negative charges. This is a plum pudding model. But what is a nuclear model? Nuclear model state that the nucleus at the center of the atom, there's a nucleus which is having the charged particles such as neutron, such as proton, and the mass is their neutron, and electrons are revolving around it. That is a nuclear model. So we want to compare, like discuss the extent to which the result of alpha particle scattering, because alpha particle scattering replaced the plum pudding model with a nuclear model of an atom. So how it justify that the nuclear model is correct? First thing, what are the observation, and then from observation, what are the conclusion? We observe most of the alpha particle will pass through. So if most of the alpha particles are able to pass through, it means major portion of the atom is empty. So if major portion of atom is empty, this statement cannot be correct, because it mentioned positive charges and the mass were spread evenly throughout the atom. If it was spread evenly throughout the atom, the positive charges and the mass, like the proton and neutron, evenly spread. So alpha particles were not be able to pass through, according to plum pudding. But because according to nuclear, neutron and protons are there inside the nucleus and electrons are revolving, so but most part of an atom is empty. So nuclear model confirmed that because most of the alpha particles are able to pass through, so major portion of the atom is empty. But plum pudding model, if it was valid, then alpha particles should not be able to pass through it. So you have to mention here the observation and the conclusion of the alpha parting scattering. So most of alpha pass through shows major portion of atom is empty. Which is contradictory to the plum pudding model. Because according to plum pudding model, the charges are evenly distributed and the mass is evenly distributed. So means alpha particles should not be able to pass through. Then few of them deflected shows the charge is there at the center, or positive charge is there at the center. And few of them bounce back, or very few rebound, shows the mass is present at the center. So how you will score 3 marks? Actually, like out of six, 3 marks are for the observations and 3 marks for the conclusion. Then question 7, also related to Rutherford experiment. Structure of an atom was investigated in early 19th by directing an alpha particle at a thin metal foil and measuring the angle through which the alpha particles are deflected. Explain why these experiments are carried out in a vacuum. So previously the same question was there of 1 mark, like why there's a vacuum. Now it's of 2 marks. So what is the distribution of the mark? First thing, we want to prevent the alpha particle to interact or hit the air molecules, because if alpha particle interact or hit the air molecule, it may stop, the alpha particle might be stopped before reaching the foil. So preventing collision between or interaction between air molecules and alpha particles. And what is the reason why we want to prevent? So alpha particles can reach the metal foil. Otherwise, if there is a air present between the source of alpha particle and the metal foil, there is a possibility that alpha particle might not reach, or there might be a possibility that alpha particles might changes the direction. Say this is the source of alpha particle, and in between we have air molecule and then the metal foil. So what might result if they collide? They might change their direction as well. That's one possibility. Or alpha particle might be stopped by the air molecule before reaching the gold foil. In one series of experiments, about 1 in 8,000 alpha particles directed at a thin foil were deflected to an angle greater than 90. Explain how this provide an evidence for an atom having a concentration of the charge in the center of in a central nuclei. Like what we observe, if these alpha particles are moving towards the atom, and the central part and size of a nucleus is very small as compared to size of an atom, and major portion of atom is empty. So how this give an evidence that the angle, like a deviation is there and greater than 90 angle is there. So how this give an evidence that there's a charge in the central part of a atom, or charge is present in a nucleus. Basically idea is that because alpha particles are charged, so if a nucleus is charged, when two charge objects are there, like charges, and they should be like in to change the angle by, like this is less than 90, but to change the angle more than 90, for alpha particle to change the angle more than 90, this nucleus must be charged, because like charges can repel each other. So alpha particle need a very large electrostatic force to deflect them through an angle greater than 90. So this shows that the nucleus must be charged, and electrostatic force between the alpha particle and the nucleus causes this deviation to be more than 90 degree. So answer here, when you will mention that we need a large force so large force is needed to deflect alpha by more than 90. So alpha particles which are closer to the nucleus experience strong electrostatic force, deflect through a large angle. So deviation, for one mark is for mentioning like the deviation to be large, we need a strong force. That is one mark. And then the second is the nucleus must be charged or electrostatic force must be strong. So, like there should be a force electrostatic because between the charges there's an electrostatic force. So strong electrostatic force can cause this deviation. The angle at which the greatest number of alpha particles was detected for a gold foil was 2.1. Like we detected about 2.1. This experiment was repeated with other metal. The highest deviation is from the gold. And you can see the proton numbers. For gold, it is 79. For silver, it's 47 proton, copper 29, and aluminum. So why aluminum is having the, like in case of aluminum, the alpha particle is having a least deviation. But in case of gold, angle of deviation is more. So what is the reason? Because gold contains 79 protons. So strong electrostatic force is there as compared to aluminum, which is having only 13 protons. So explain the pattern of results in the table. So how we explain the pattern of result in the table? Like the greater angle or deviation is there with a greater proton number. You can clearly see from the numbers result. And the greater proton number means there's a greater charge or strong repulsion is there or electrostatic force. That's why it is large deviation. You just have to interpret the table in your own words. And part D, these experiments provide evidence for a nuclear atom. Like it shows that what is the meaning of a nuclear atom or it means like a nucleus is there inside an atom which is having neutron and protons, and around the nucleus the electrons are moving. Bohr suggested that electron can only orbit the nucleus at a specific distance. This was the idea of a Neil Bohr who gave explanation that before it was the concept was there that electrons are moving, but there was no concept of the orbit. So Neil Bohr was the one who gave an idea that electrons can move in a specific region, which he called that as a shell or orbit. So de Broglie developed this idea by stating that the lowest possible orbit in which the circumference of orbit is equal to de Broglie wavelength for electron. So by considering the force keeping the electron in an orbit around hydrogen nucleus, this statement is true. The radius of the orbit is 5.29 exponent minus 11 meter. So what de Broglie developed an idea, he said that the lowest possible orbit where the circumference of the orbit is equal to de Broglie wavelength for electron. So when we work out the de Broglie wavelength of the circumference of the orbit, that is the lowest possible. When the de Broglie wavelength, which is lambda, is equals to circumference, which is 2 pi r. So it means the value of the lambda and the value of 2 pi r should be same. That when these two are same, it means that is the lowest possible orbit. So radius is given. We have, and for which hydrogen is there, for hydrogen it's having one proton and there is only one electron around it. So de Broglie wavelength, we have the for lambda is equals to h over mb. The de Broglie wavelength lambda equal h divided by mb, where v or h in divided by p, which is where p will be the momentum. And how we can work out the value of v. And the circumference is 2 pi r because we want to show that that value of the lambda, when we calculate the value of the lambda, it will be same as the value for 2 pi r or the circumference, where h is a Planck's constant, which is having a value 6.63 into 10 power minus 34. M is the mass of electron, where V is the speed at which the electron is moving. How we can work out this? So first, because when the electron is moving around, as this electron is moving in a circular path, so we can say whenever object move in a circular path, the force is called centripetal force. So in this case, the centripetal force will be equal to the electrostatic force. So centripetal force is given by a formula mv square over r. And electrostatic force, force between the charges, that is given by a formula k q1 q2 over r square. When I simplify r, this will cancel with the square. So it will be mv square is equals to k q1 q2 over r. So, or this will go there in division. So v square is equals to k q1 q2 over mr. And then we'll take a root where k is a constant which we have already, because to get the lambda we need h is a constant which will be given in exam. You don't have to memorize, but if you remember, that's good, which is 6.64 or 6.63 exponent minus 34. M is the mass of the electron, which is 9.11 exponent minus 31. That is also constant. The thing is we need v, but how to get v? As this electron is moving around, as this electron is moving around, there, whenever object move in a circular path, there is a centripetal force. And because this time the centripetal force is equals to the electrostatic force, so electrostatic force is k q1 q2 over r square. So when we simplify this, we'll get the value. To get the value of V, it will be k. Q1 is the charge of proton, Q2 is the charge of electron, which is same 1.6 exponent minus 19. M is the mass of electron, and r is the radius in which it is moving that they provide. So we'll take a root that will give us the value for V. After getting the value of V, we'll get the value for lambda. And then because we want to show that when electron move in a shortest radius or in the first shell, the wavelength associated with the electron equals to the circumference. So wavelength will be equal to circumference, which is equals to 2 pi r. So get the value for lambda, get the value of C, and then compare the two results. And you will find that the two values will be equal. In question 8, so in a Moscow Meson factory, the linear accelerator or LINAC is used in the production of particular isotope for medical. Strontium 82 is created by bombarding rubidium 85 with a proton. Complete a nuclear equation. So first for a neutron, because if it's a neutron, it should be 1 and 0. The total number, and if it's a proton, proton is the, because this is representing like a nucleon number, which is a sum of neutron and proton. So for proton, it is 1, and this is representing a charge. So for charge also, proton is 1. So if in a nuclear equation, if we have electron, we write 0 and minus 1. If we have proton, we write 1 and 1. And if we have neutron, we write 1 and 0 for a nuclear equations. As an electron does not have any nucleon number, that's why it is 0 and the charge is minus 1. Proton nucleon number is 1 and charge is also plus 1. And neutron nucleon number is 1, but it does not have charge, so it will be 0. So sum in the reactant and the product side should be equal. So this is 1 plus 85, so total is 86. And this one is 82. So we need, and this is 1, so we need total 86. So how many neutrons should be there? 4. And what about the atomic number? Sum should be same. Here it is 0. So 37 plus 1, so this will be 38. So this is a nuclear equation for converting rubidium into strontium. So Moscow Meson factory accelerate the proton up to energy of 160 mega electron volt. So this is before these protons come out, they have the energy of about 160 mega electron volt before they collide with the rubidium. The first 100 mega electron volt is supplied using a LINAC with a drift speed, as shown. Explain how a LINAC accelerator accelerate the proton. A 4-mark question, you have to explain the working of LINAC or a linear particle accelerator. So what are the points for a linear particle accelerator? First thing, these adjacent tubes have opposite polarities. What does it mean? Adjacent tubes have opposite polarity. Like if this is plus minus, then it will be plus minus. Like adjacent tube, like this is one side of a tube, this is another tube. So they always have opposite polarity. This is always the case. Same thing if one side is negative, other positive. Negative, positive, negative, positive. So the first point, whenever you explain about the linear particle accelerator, you will always mention that when we have the adjacent tubes, have different polarities. Or different poles are there on the adjacent tubes. Then there is an electric field between the tubes and there is also an electric field in the gaps. But this electric field between the tubes is responsible for accelerating. So when there's an electric field between the tubes, that causes a proton to accelerate or proton to move. So when the proton is there, moving within the tube, it's not accelerating. But when it come out, that same moment when it come out, opposite polarity it will experience. Like when it is inside, say this one is positive, negative, positive, negative, positive, negative, positive, negative. The moment this electron will come out, the polarity will change. Then it will be positive, negative, positive, negative, positive, negative. So this electron will the proton will accelerate between the tubes. But when it enters the tube, again, net resultant electric field when it is moving at the center, it's cancel out. So it is not accelerating between the tubes. It only accelerate when it it'll come out from one tube. So there is no acceleration within the tube, only acceleration is there between the tubes. So adjacent tubes will have different polarities. As these adjacent tubes have different polarities, the proton will accelerate or there's an electric field between the tubes. As a result of these electric fields, what will happen? The proton will accelerate and it takes the same time in each tube. So whenever, like example, if this proton is taking say 2 seconds to cross the first tube, same 2 seconds, same 2 seconds, same 2 seconds. How the time is same even though the length of the tubes are different? As the length of the tubes are different, but the speed is also changing. We have the formula speed is distance over time. So time is distance divided by speed. The distance is increasing, speed is also increasing. So ratio between them remain constant. That's why the protons will take same time in each tube. And so when they're taking same time in each tube, whenever they reach one end of a tube, they will always receive the same polarity. So they will accelerate. We can accelerate this proton to about 100 mega electron volt. But then what will happen? Why not to 160 by this way? Because when the particles are moving at a high speed, close to the speed of the light, the mass does not remain same. Mass changes. As a result, due to relativistic effect, the mass change. So we cannot have a perfect proton in which that it take the same time in each tube. As the mass change, the acceleration will also change. The diagram shows a path of proton in a line arc. Point A and B are at the center of the two successive gaps between the drift tubes. An AC supply, which is having a frequency of 198 megahertz, the average kinetic energy of a proton as it moves from A to B is about 2 mega electron volt. Calculate the distance between A and B. You may assume that the proton speed is non-relativistic. What does it mean, non-relativistic? It means like it does not accelerate or not moving with the speed of light or close to speed of a light. So look, the frequency is given. To get the speed from like to get the distance between A and B, basically it's like we consider it's a length of one, or it's a bit more than length of one. So we have the formula speed is equals to distance over time. So if we need distance between A and B, distance between A and B is speed multiplied by time. So we need the speed and we need the time, because when this proton will enter the tube, it will not accelerate. So what speed it was having here, same speed it will reach around B. Then when it reaches the center, then only it will accelerate. So we consider the speed is not changing. That's why distance is speed multiplied by time. But if the speed changes, then we cannot use this formula. Then we have to use the equations of the motion. So how to solve such question? The frequency is given. So using a frequency, we can work out the time, because that will be the time taken. Because when the polarities changes, you can work out how much time it will take to change the polarity, because it when this, as we know, every time it will receive the same potential. Like first say this was negative, uh, because it's a proton. So this is negative positive, this will be negative positive. When a proton is there, reaches the other plate, first like it is at position A, this is negative positive negative positive. Then when the proton is there between the tube, the terminal will change, that will be negative positive negative positive. But like the terminal change positive negative, like here when the proton is here, because it must be accelerated, so this will be positive negative positive negative. So it accelerated here due to electric field. When it is accelerated, inside it won't changes the speed. So as it does not change the speed, the moment when this proton is moving within the tubes, the terminal changes negative positive negative positive. But when it reach outside, like when it will be outside again, the terminal again changes, become positive negative. So means how many times the terminals are changing every second, that is called a frequency. This one is, which is 900 and 198 megahertz. So 198 into 10 to the power 6 times it is changing every second. We need the time period. We want how much time it will take for a terminal to change back again to the same value. That is called a time period. So using a frequency is reciprocal of the time period. We'll find the time period which is reciprocal of frequency. So 1 divided by 198 into 10 to the power 6. Because it's a mega, as it is in megahertz, you have to convert into hertz. And then take a reciprocal. This will be 5.1 into 10 to the power minus 9 second. That is the time it will take to move from one place to another. The second thing, we need the speed. How to work out the speed? They give us the kinetic energy. That is, it is 2 mega electron volt. But remember, the SI unit of energy is joule. So you have to first convert this mega electron volt into joule before getting the final answer. So how to convert 2 mega electron volts into joules? So 2 mega means it will be 2 into 10 to the power 6 electron volt. And 1 electron volt is equals to 1.6 into 10 to the power minus 19 joules. So 2 exponent 6 will be x. We cross multiply. So basically what we have to do, we have to multiply 2 into 10 to the power 6 with 1.6 into 10 to the power minus 19. When we multiply them, we will get the answer in joules. And after getting like this kinetic, this will be 3.2 to 10 to the power minus 13 joules. After getting this energy in joules, we'll use the kinetic energy to work out the speed. So Ke or Ek is equals to half mv square. So we have the kinetic energy, we have the mass of proton, which is uh, will be given in the exam 1.6 exponent minus 27 kg. So using that, we'll work out the speed. And from speed, because we want the distance here, so distance is speed multiplied by time. So speed will be there and time we already calculated. So we'll know what is the distance between A and B.